Hi, with Patrick here, discussing an implementation of the game of Yum using Q-Learning. And in this fourth video on the subject, I'd like to demonstrate a little bit further what the program is doing for playing these games. So if I share my screen right away, because what I want to do now, it takes a little bit of a while to run. So I'm just going to start. I'm just going to start it here, and we're going to talk about it as it's running. So if you remember, maybe from two videos ago, we ran together through a single game using the agent as the entity who was running the game completely. So what he was doing is when there was an initial roll, and the agent would look at the dice and decide which dice to keep, and then during one turn, and then during that turn, he's got a maximum of 2 rerolls remaining. For each reroll, he's going to decide again which dice to keep, and at the end of the turn, the same agent again is going to score that into one of the 11 possible categories. And we saw we ran a pretty good game together that we ended up with 200 as the score, which was a pretty good score. If I recall correctly, the only category that we did not score that we scratched actually was the high. But that's just one game. Obviously, as you're going to be playing, as the agent is going to be playing more and more games, we want to get a sense of what's going to be the average score of this agent. So maybe with that game there of 200, maybe we just got really lucky, and it just so happened that we had 200, but that was a one-off. But indeed, 200 is a pretty high score. But that begs the question: what is in Yum, what is a good score versus a bad score? And so as I was working on this project, I wanted to get a sense of what's a good score and what's a bad score. So I played a certain number of games by myself, with no computer support, anything like that. When I say computer support, I mean with an agent, another agent helping me choose the dice to keep and choose the category to score. Just played in individual games, and I played about 70 games, which is starting to be good enough to know approximately what, as a player, as a human player, what's reasonable for that. Now, am I a good Yum player or a bad Yum player? It's hard to say, really, because I don't have any data on what other people have been able to accomplish with that game. So regardless, I went ahead and I played about 70 games by myself, and I ended up having an average score of about 150, which is kind of reasonable. So 150, I can go a little bit in the breakdown of how I did in each category and things like that. But suffice it to say that 150 would probably rate me as as an average, reasonable human player. And the thing that would be interesting really to find out is that if we're able to do about the same with some sort of algorithm, and so what I did right at the start of this video here, I started the play routine again, so the same one that we use to run a single game, but I just changed some switches in the code so that it would run 1,000 games, not just one, and also that they would do without the narration, the description of the game as it was going on, that it's not going to be saying like every roll what's happening at every turn, where where you're at in the scores. It's just going to blast through one game, and after that another one, and as you see here, it's going through it's about halfway through a 1,000 games, and it's going to be accumulating all those results, and a few more minutes more, and we're going to have an idea as to what the agent is able to accomplish as an average score. Maybe during that time, we still have a few minutes here. One thing that I didn't mention in the previous video, that when I was talking about Q tables, which is central to all of this really, is that this particular implementation here uses two Q tables. Okay, so there's one of the Q tables is specifically concerned with the keeping of the dice. So it's going to look at what dice are there, and it's going to look up where it's at in the game, in the sense that what categories have been scored, and it's going to decide which dice to keep. Okay, and at the end of the turn, there's another Q table that takes over, and which is going to score the category. So you've got two distinct Q tables that, by the way, they both need to be trained individually. So, for example, so in the code here in the repo that I'm about to release publicly, one of the instructions I give is that if you want to do a training yourself, and regenerate different Q tables, what you're going to be wanting to do is first you're going to be wanting to train the scoring table, and after that you're going to be wanting to run the training on the keeping. And you're not going to see that on Git. You're not going to see the Q tables that are built up, that are developed during the training. And the reason for that is that you might recall from my previous video that the Q tables are going to be large because there's 500,000 rows, and both those Q tables, by the way, the scoring Q table and the keeping Q table, they have the same rows. It's the same number of rows, and it's the same organization as I showed before, with the dice dictionary and the categories that have been scored. And so both of them is 500,000 rows, and they're in the same order, and they represent the same thing. But of course, the actions are going to be different. In the Q table for the keeping, then it's all actions that are related to which dice you're going to be keeping. Are you keeping the ones, the twos, or you going to be doing some cross actions, for example? Are you going to be keeping the ones and the threes, or the ones, the threes and the fours, for example, or anything else like that? Or are you going to keep nothing, or are you going to do that K4 action that I explained also? So that's for the keeping table. In the scoring table, the action is kind of simpler, really. It's for each row there, it's going to be scoring a category. That's so there's going to be really 11 columns, right? And each column there is going to have a maximum at one place, and that one place is going to be scoring that particular category. So for example, if you have a situation that you look at your rows, and you have one row that's 4 threes, okay, and a 1, and the threes have not been scored, then to be sure the maximum of that row is going to fall under the category of the 3, so that you're going to be scoring that. And so, but if I look numerically, well, not numerically, but at the size of those Q tables, the keeping Q table is about 260 meg. So that's quite large, and they won't take it on GitHub. And the scoring Q table is a little bit smaller. It's kind of a lot smaller, actually. It's about 40 meg, but I think also that one is also not acceptable on Git. But But so I said earlier that you can download this repo and it will work right away. And then you might be saying, well, if the Q tables aren't there, then how is it going to work right away? Well, I also have some reduced Q tables that are up there that essentially, once you're done, there's only really in your columns, there's only one column that matters, is the maximum. So for each row, if you look at the Q table for the actions, there's 61 columns, but only one matters, only the winner. So you can reduce that dramatically by going, and actually, so the Q tables that are on Git, the two of them, the scoring is 1 meg, is down to 1 meg, and the keeping Q table is down to 1 meg as well. And so that's why when I say that you can download that and it will work right away, because for the play, for example, if you download and you run play, it's going to use those the reduced Q tables to play directly. But if you're doing a training, though, it's different. It's gonna when it's gonna start the training, it's going to explode the Q tables to full size while it's doing the training, and after the training, it's going to reduce everything, and then you can delete the large Q tables if you want. Okay, so all right, so it just finished running 1,000 games. And the reason why also in the readme.md.markdown in Git, I say that one of the things you have to install is matplotlib, and the only place I'm using it is here in the games, and just to generate the histogram of the game. So here you have it. The histogram is not super interesting, but what's more interesting is the results here right there. Okay, so what happened? So in 1,000 games, well, we had an average score of almost 152, right? And I just said earlier that my personal average after 70 games is 151. So we're pretty much neck to neck here between myself and the agent. Now, of course, there's going to be a spread. The worst game was 67, that's a pretty bad score, but the max score is a whopping 237, which is good. And okay, so now one thing I really like to show is the breakdown of the categories. So the bonus, as you might recall, that the bonus happens when you've scored a total of 63 or better above the line. And here the bonus, it got it essentially 629 times out of 1,000. So 63% of the time of games it got the bonus, which is pretty good. And here, so Yum, that's 5 of a kind, and really that's just almost pure luck, but still got it 15%, which is not bad. And so the straight it did a bit better than a third. So 38% of the time it got the straight. That's a bit I can explain a bit. That's a bit the weak point of the agent, I find, is that he's a little bit low on the straight count. But the reason for that is that I might go into more detail about that later on. Is that the reward scheme is biased towards the bonus. So I mean that there's several different strategies that you could take for playing the game of Yum, and one of them is to be biased towards the bonus, which this agent is, and as proof he's getting the bonus a lot of times. But is it at the expense of the straight? The straight is a little low. The full, I find, is not so bad. I'd like to see it a little bit higher too, but this is pretty close to where I'm comfortable with it. And the low and the high here are actually pretty good. So you see the low, the agent is getting it almost all the time. 98.6% of the time, and the high about 2/3 of the time. So in the 70 games that I played, I did some sort of similar breakdown too. And the bonus, I don't get it as often as the agent here. So he's at 63. I'm about 57%. And the straight, I do better on the straight. I'm about 45% on the straight. And the full, I'm slightly better than that as well. I'm about 80%. And the low, I'm about 94, 95% of the time. And the high we're about the same. We're about equivalent on the high, about 2/3. That's what I get as well. And the yum, he's actually beating me on the yum. He's getting it 15%, and I'm getting 10, 11%. Yeah. So one thing that I maybe would like to show here would be, if you can bear with me for a sec, because one thing that's very interesting is, okay, so we've got all these games here. And these games, I print them out so that I can look at them. And so, and which was very helpful during the development of this program here, because I can look at games, you know, and see kind of like what happened. And so, for example, here we could definitely look at okay. So let's go ahead and look at maybe the worst game here, which is 67. Okay. And so 67. So that's awfully low. Let's check out why this was. Okay, so I just did a search here in games.txt, which is the record of all of these 1,000 games here that we played. Okay, so here's the end of it, and we didn't get the bonus, not surprisingly. And turn one, just going to go quickly here. So he scored 8 in the twos, which isn't bad. He scored the low. Okay, he scratched the yum, scored 2 in the ones, scratched the full. He scored 3 sixes, which is not bad, 18. Here, unfortunately, he had to scratch the straight. Scored 9 in the 3, so you can tell that it's a bias towards the bonus, because he's doing still not so bad above the line here. So here's 9 in the 3s, and unfortunately, so he scratched the high. And here in the end here, so the last 2 categories here that he only had the 5s and the 4s left. Started with 2 5s, okay. Next reroll again, 2 5s. And then in the end, so he doesn't want to score only 2 5s, so he's got 1 4, so he's scoring a 4. And here the last turn here, only the 5s left. So no 5s here, so he's keeping nothing. And here he's got only 1 5, and so he's keeping it, but he's ending up only with 1 5. So unfortunately, that was not a very good game. So why don't we look at, as you know, just to close on this video, let's look at this best game here. What could have happened? Game 936, 237. So that's the best game. All right. So here, the first one. So he scored the full right away on turn 1. Oh, got the yum. And yeah, so a yum in 6s. That's kind of debatable if you should score that in yum or the 6s, but usually when he sees a yum, he's going to score it in yum, which I don't mind, because yum is kind of rare. You rarely get that. And so he got the straight at turn 3 right away. Bang, scored it right away. And here's scored 20 in the 5s. Yeah, that's good. And oh my, he's got again lots of 6s here. Scored 30 in the 6s, 12 in the 4s, and he's got a big high here at the 26. And oh wow, he's got like 5 1s, so that's another yum almost. And here he's scoring 21 in the low, 12 in the 3s. Yeah, 4 3s. That's great, and 6 in the 2s. Yeah, so that was an awfully good game. Okay, so here I just wanted to show this here, how the agent is doing on more than just one game, but how is he going to be doing on 1,000 games, which is definitely representative of the capabilities. If I were to run that again, which I have in the past here, I would get about the same thing here, about a score of about like 150, maybe 151, sometimes even 152 or 3. So it's pretty much it's pretty stable at this score. Okay, so well, again, thanks for your attention, and there's going to be more videos coming in which we'll talk about other things. For example, I'm thinking of shortly would be to demonstrate how to pull this project and into PyCharm, so that everybody can look at this at their leisure. Okay, so thank you for your attention again, and hope to see you again real soon.